All right, everybody, we are doing the classwork test review systems number 1. We're still going to be doing systems after this test. For this test review, we're just going to kind of get through it. We do have like a front, back, front, so we do have a couple questions. It's a lot of room, a lot of big papers, but it's actually not that many questions. We'll see. So, number 1. All of this space up here is going to take us about 30 seconds, okay? What is the solution to the system graphed below? Well, we have one solution, I can tell, so let's go ahead and list that. You know, we definitely have one solution. But if we ever have one solution, which I can see right here, it's always a good idea to tell me exactly what that solution is. I know it's a Monday morning. What do you think about that exact coordinate? Nice. Very good job on a Monday. -1, +2, waking our brains up a little bit. How many solutions do we have for number 2? Right, no solutions, 0 solutions, however you want to say it. I'm with you. All those sound good to me. These 2 lines, they don't touch, so no solutions. And this third one, before you just say infinite solutions, we don't have an infinite solutions graph. We actually have, you know, again, a little one solution graph. I think we all kind of understand infinite solutions at this point. What do you think for this intersection? 1, 5. Perfect. Very, very good job, everybody. We're moving on. We're keeping it going. Stay with me. 1, 5. All right. We've got 2 graphs here. These are not inequalities. These are just straight up equations. And so all we need to do is graph these. We are going to need to write our solution as ordered pair there. And we don't have a lot of room to write the m equals and the b equals. So maybe you can go at the bottom, right? So for the first line, I'm going to say m equals 2/1 and b equals -1. So I'm going to start at -1. I'm going to go up 2, and I should be moving to the right because this is a positive slope. So 2, 1, 2, 1. Now, when you're doing these particular questions and you're using equations, that's when you're looking for perfect intersections. So it is a big advantage to extend your lines with these dots because we do want these lines to be perfect. All right, this is where if I draw a real squiggly line, it's going to look a little bit like a mess. Go ahead and draw a line like that, and then our second one is going to be m equals -1/1 and b equals 5. Start at 5. And this time with the negative, I should be traveling left for my run. So my rise is 1, my run is 1. Again, it's a good idea to extend those dots as much as you can until you see that perfect intersection. And this one's kind of nice, right? Here it is, right there. Draw a line. And I can see that this is our intersection. And the coordinate for that looks like we went in the x direction 1, 2. 2 in the x direction. And in the y direction 1, 2, 3. +2, +3. We're just going to kind of keep going. It's just a warm-up, just a review, but we do have a lot of questions to get through to make sure we cover everything before the test tomorrow. M equals B equals. I hope that the graphing stuff is feeling not too bad at this point. We have a -2, so I'm going up and left. Again, I like to just kind of extend it as much as I can, because we're looking for those perfect intersections. The second one is 3/2 and +2. That means I should be going run, rise over run, up 3 over 2, up 3 over 2, up 3 over 2. kind of getting that nice little pattern of doing this. And I can see it looks like right here is my perfect intersection. That intersection is at, it's getting a little tricky to see. Here's my origin right here. So I need to go left 1, 2, -2, and down 1. -2, -1. All right, there's that front of the piece of paper. We worked through it. We did, honestly, that is some of the slowest, kind of biggest graphs we have to do. We're going to be moving on in about 10 seconds. I know I was going maybe a little bit fast. Any questions? We're feeling okay about these graphs? All right, going to the back. On the back, we're talking about solutions to inequalities. So when we have inequalities, that's when we start to color. Remember, whenever we have the double shaded region, or when they do it like this, if we only have one shaded region, and that's what we're looking for, that's where we're going to find all of these kind of points. So down here, it would be in this region. And number 6 is asking us a very important point. I'm going to go ahead and put a little bit of like a highlighter box on it. 1, 1, what do you think? Yes or no solution? Nice job. I'm going with no. It is right on the corner, and we do have a solid line, but we also have a dashed line. And the reality is, dashed line bad. If you are ever on a dashed line, dash line bad. My D's always look like O's. There's nothing I can do about it. Dash line bad. Number 7, we get 5 different coordinates. -1, 0 tells me to go left 1, which is right here. Honestly, that's not even close. Maybe I'll do a little NS for not solution. 3, 0 tells me to go to the right. 1, 2, 3. 1, 2, 3. That's right here. That does look like a nice solution because it's nice and in the shaded region. This -1 tells me to go down because it's in the Y position, so that's going to tell me to go right here. Here's our first kind of difficult one. It's right on the line. It is on a dashed line. So that is a no solution. Or really I should say not solution, but dashed line does not count. 4, 0 tells me to go right 4. 1, 2, 3, 4. This is the same thing, right? I'm on that dashed line. That's going to be a not solution. And what do you think about this last one? I've done 4 of these for you. You help me out with 1. Solution or not solution for 2? Heard somebody say it, and they're correct. Solution. 2, -1 means go right 2, down 1. That puts me right here, firmly in the positive side. There's definitely questions like this on the test where you have to determine if they're solutions or not. Making some great time. We are pushing through a lot of these questions. We're almost on the back here. We're powering through for sure. Number 8 and 9 ask you to do the shading. They're on the sideboard over there if you're in class. If you don't remember, I guess we'll just kind of go that we have solid and dash lines. I guess I did that differently on the board. Either way you do it is fine. I'll do it over here, I guess. We have above and below inequalities. We have dash and we have solid inequalities. And so the above is going to be the greater than or equal to, and the below is going to be the less than or equal to. So I can already hear some people coloring, which is a good sign for me. When we're doing 8, the top is line 1, and I see that we have a less than. And that less than I see right here in this position, which means it is a below. So I'm going to color below line 1 like that. Everybody cool with how I ended up with that below coloring? Line number 2 is this one, and line number 2 has a greater than or equal to, which is why it's solid. And the greater than I can see right here, that is an above coloring. So I need to color above the the red line, wrong color there, above the red, which is that portion. So remember, whenever you do this, you should have an empty side, an only red, an only orange, and a both colors. This section right here, that is the section that we want. This section right here. All right, let's do the same thing for number 9. We have line number 1, which is this dashed line here. And I see that this is a less than, and the less than I see in this position, which is a below. So I'm going to be coloring below. Doesn't have to be perfect. And then I'm going to be looking at the second one, which is a greater than or equal to. And so line 2 needs to be greater than, which I see right here. That is an above coloring. So I'm going to color this. Now I do want to point out just for a second that for number 8 we had less than, greater than, and we were this right piece. And for number 9 we had the same thing, less than, greater than, and we ended up with this right piece as the answer. So really when it comes to this stuff, you have to like avoid shortcuts, right? Don't try to come up with some secret strategy that works or something like that. Just do it the way you're supposed to do it, okay? Whenever I see students who get questions wrong on the test, and I'm like, dude, that was the easy question on the test, they're always like, I thought that you could, if you calculated the thing. Don't overcomplicate it. Just do your coloring above or below. Number 10, I'm sure we have some people working ahead of me here. Did anybody get a letter already? A, B, C, D, which one do you think it is? A couple people said C. Proud of you guys for working so fast. We're doing so well with this. We have a less than or equal to, which means we should be less than. Now, I do want to look. How do I know which line's which? This one says 2, which is my y-intercept, which I can see right here. So that's telling me that this is my top line, and I need to color less than that line, which is below. So far, C does look promising. Line, section D is a possibility. That means that this one must be red. It is a greater than. We need to color this side. And everybody that said C, nice job. You are exactly right. C is the perfect answer. Feeling good? Doing well? All right, we're on to the last page. Again, sorry that you have, I really hate giving you guys 2 pieces of paper, but it is kind of our review for the test tomorrow. We've got a couple questions on here at the top. This might look like a lot of work. Number 12 is going to be a pretty easy question. Number 11 also, I mean, it's not that bad. Again, for this one, we don't really have a lot of room to do our M's and B's. So, got to be a little bit careful. Positive 2, I'm going left because it's negative. For these ones, we don't need like the perfect line. We're not looking for the exact intersection. We're just looking for the big shaded regions. So I don't need to do 100 dots. It's fine if you want to do a whole bunch of dots. But for these ones, it's more about the big picture than the preciseness. What is important is that this is a less than symbol, which means we need to do a dashed line. So if you were kind of working ahead of me, and maybe you did a solid line because you were working too fast, just be careful, slow down. With this less than line, it also is a shaded below. So I'm going to shade below. The top one we can color with red. That's m equals 3/2, b equals 2. And so we're going to have the same exact y-intercept, which makes things easy. And we need to go up 3 and right 2. 1, 2, 3, 2, 1, 2, 3, 2. Again, we don't need 100 of these little dots. We just need the general idea. This is a less than equal to, which means we are going solid line on this. And since this is a less than, we need to color below the line. Again, my best strategy as a teacher is think of this line like a roof. So if you're not sure which one is above, which one is below, to me, whenever I picture a roof, it kind of helps me out. And so this section down here is the section that we're looking for. All right, we talked about this. This is as hard of a graphing question as there possibly exists in Algebra 1. And we did this question, I mean, it might have taken us 90 seconds, right? Nice job. If you're feeling confident with this, you are a bit of a graph master. Let's check out number 12. The top one. So this is really interesting for number 12. It's not difficult, but I do want to talk about it for a second, okay? We've got the orange line and the red line here, the top and the bottom. Okay. When it comes to let's talk about the orange line first. Does this orange line count as a horizontal line, a vertical line, or a normal diagonal line? I've heard vertical, I heard horizontal, and the bad news is this is a normal diagonal line. The reason that this is a diagonal line is because we have the letter Y and the letter X. If you have both letters, that's a normal graph. That means you have the M from in front of the X. That means you have the B from after the X. And so for this question, we still have M equals -1 and B equals 0. Now, when you look at the red graph, or the bottom one, does this one have the Y and the X? No. So this is going to be a horizontal side-to-side graph. And before we graph either one, they are both inequalities without the equal sign. So these are going to be both dashed lines. So we're going to start at 0. We're going to be going up 1, left 1. 0, up 1, left 1, up 1, left 1. And with a dashed line, again, that top orange line is a normal diagonal line because it has a Y and an X. Then we're going to go with our red line. This one is a horizontal line. So if I start at -4, the slope of this line is 0. So I'm going with a flat across line. Now I did kind of do this in a little bit of a wrong order because I forgot to color my first graph. So if we go back to the orange graph, which is a less than, This diagonal line should be less than. It should be colored on this side. And then my horizontal bottom red graph is a greater than, so it should be an above coloring. So I should color it like that, above the red line. Again, you always want to just kind of check. We have an empty corner. We have a corner with only red. We have a corner with only orange. And then we have the double colored region. This is the region that we like. This is the region that has all the solutions. All right, if you can graph number 12, like we said, you are a graphing wizard for sure. 3 questions left, period, as she said. Big agree. What, she can say period and I can't say period? Come on. I know, I'm getting old. What's up, man? Did you make a pass to me? It's not quite open yet. We'll do a written one. Here you go, man. 10:08 is when you should be back. All right, so down here we got elimination. This is the last thing that we've done. Remember, with elimination, we're looking at these letters. We're looking for a perfect setup. Sometimes it is a perfect setup. We can just go. Sometimes it's not a perfect setup, and we have to do a little bit of a subtraction or a sign switch. So for number 13, when I look at these X's, are these perfectly set up where they're gonna cross out right away? Focus, focus. There we go. What do you think about the X's? Are these perfectly set up so they're gonna cross out? Yeah. Yes. We have 6 minus 6. That makes 0. This is gonna be a very easy question. We can go straight to the addition parts. 6 minus 6 is going to make 0. Negative 10 plus 9. Anybody know what that is? Negative 1. That's correct. We're just adding these things straight up, right? We're just going, boom, add them up. Negative 10 plus 9. Then we're going to add these up. Boom. Negative 2 plus 6. Positive 4. The positive 6 is bigger, so it's going to kind of overpower the negative 2, and we're going to be left over with a negative 4. And we always finish with a one-step divide. What is negative 4? Sorry, positive 4 divided by negative 1. Yes, I got ahead of myself, and I was already thinking about the answer. So we've got negative 4. Now remember, that is half of the answer. It is the second half because the y always comes second. And what we need to do is take this y and put it back into the y. I heard the answer is 7. Let's see if I can write this down correctly. I did make a mistake earlier in the year. Putting this y into the y, so I should have negative 6x. I don't need to change the x. Minus 10y. This is where I need to put the 4 into the y. Negative 4 equals negative 2. And with all of this, you know, you can probably solve it in your head, maybe solve it on paper, or you can use the all-powerful Omega Desmos. Type it in how it looks. Negative 6x minus 10, parentheses, negative 4 equals negative 2. I heard the answer was 7. I'm looking at 7. Nice job, everybody. Couple geniuses in class this morning. Proud of you. There we go. 7, negative 4. All right, we got basically 2 questions left. Number 16 is a joke. It's so easy. Getting started on number 14. This is really the last thing we have to cover. Are the x's perfectly going to cross off? No. Negative 1 plus 3 does not make 0. What about 3 plus 3? Does 3 plus 3 equal 0? No. 3 plus 3 makes 6. So this is what we talked about, where we're going to take this top one and we're going to write it underneath here with total opposite signs. So my negative 1x is going to become positive 1x. Total opposites. Positive 3y, negative 3y. And when it comes to the 0, a 0 is just a 0, right? There's no such thing as a positive 0. There's no such thing as a negative 0. 0 is just its own weirdo. So there we go. Opposite sign, and as far as the 0, I guess you could say opposite sign. I'm going to get rid of that top one because we now have the new and improved bottom version. And we did this on purpose because we have 3 minus 3. If you're solving these questions and you're thinking, all right, I know how to do the negative piece, but I don't know why we do the negative part, it's because we're trying to set up 3 minus 3 makes 0. All right, we're going to do addition. This is going to happen really quick for us. The y's are going to cross off. 3 plus 1 is 4 equals 12 plus 0 is 12. A really easy divide. And we get x equals 3. Now that's only half of our answer. This time, the x is the first half of our answer. And then we need to take the 3 and make sure it goes into the x part. Not the y part like the last question, but the x part. So this 3 goes in there. We should have 3x. That's where our 3 needs to go. Plus 3y equals 12. Again, the 3 replaces the x. Oh, my big head in the way. Oh, please. And we go to Desmos and we type this in and we get an answer. Anybody got one already? Can't tell if somebody said 9 or if they just kind of mumbled. 1 is what I'm checking out. Let's see. It's a 1. And so 3 comma 1. Basically the last question again because number 16 is so easy. I'm going to go quickly through this question. Here we go. I'm going to look at the top. I'm going to rewrite it. I see that 1 plus 1 makes 2. That doesn't work. 3 plus 1 makes 4. That doesn't work. So I'm going to rewrite it. Negative 1x, negative 3y equals negative 9. Now that I've rewritten it, I'm going to go ahead and scribble this out. I'm going to put a plus. 1 minus 1, that is exactly what I wanted. I did this on purpose. 1 minus 1 is 0. 1 minus 3 is negative 2. And 7 minus 9 is also negative 2. Again, if you're not sure about those little, adding and subtracting type stuff, you can use Desmos. Divide, negative, negative. 2 negatives makes a positive. 2 divided by 2 is 1. And so I'm getting y equals 1. I forgot to circle my answer on the last one. Y equals 1, but that's only half my answer. That 1 is in the y position, and I need to plug it in to the y value. Honestly, if you are kind of struggling with how to do this, plug it back in step, I'm telling you, this arrow is actually really nice. Like, draw the arrow straight from the y to the y. It's not too bad. 1x plus 1 times 1 equals 7. Kind of a strange thing to type in. I know I could definitely do this one in my head, but let's use Desmos. 1x plus 1 times 1 equals 7. 6. All right. There we go. That's pretty much all the questions like I've been saying because number 16 is so easy. Number 16 says cross out the variables that will eliminate in the system below. Final one. Which one is it? The x's or the y's? The x's. See ya. Cross them out. Okay, that is the whole review. Nice job. Proud of you, everybody. We did a lot. Remember your one solution, no solution. Remember your graphing. That's not too bad. Remember, dash line bad. This was the question I put a highlighter on. Even if you're on solid and dashed, dash line bad. And then we finished with these eliminations. Take your time, plug it in carefully. I like these arrows that draw straight on top. And yeah, that's what we got. Nice job.